This conference will now be recorded.
Hello, everybody. Thank you so much for joining us for the Satellite Book Club Series session number 99. I am Jordan Girth with the National Weather Service Office of Observations. The title of our presentation is Lakeshore Flooding over Western Lake Superior, Forecast and Impact Challenges. Our presenter is Justin Schultz, meteorologist at the Weather Forecast Office in Duluth, Minnesota. Our facilitator is William Straka, researcher from the Cooperative Institute for Meteorological Satellite Studies in Madison, Wisconsin. You heard it here. We just had, this is number 99. We're going to be celebrating the 100th session of the Satellite Book Club next week, June 2nd, 2022. It will be at a new time next week at 11 a.m. Eastern Time when Brian Curran and Devin Chihek from the Weather Forecast Office in Midland, Texas are going to revisit a May 2021 tornadic supercell. We're hoping to have a couple special appearances, potentially from John Murphy at the Weather Service and Pam Sullivan from the GOES-R program. So please celebrate with us next week as we hit this important milestone of the Satellite Book Club. Just a few reminders before we get started that this session is being recorded. There'll be an opportunity for Q&A after the presentation. Please sign in with your full name or mention your full name in the chat when you're asking a question if you're using an office account. That helps us follow up. Particularly interested in questions, or maybe you just have a comment that you'd like to share from Forecast Office and Regional Headquarters. As we move beyond the 100 Satellite Book Club seminar, we're looking for additional presenters, particularly from the field offices, to share applications or forecast problems where satellite imagery and products may be helpful. And if you're looking for training materials, Brian Mott at the Office of the Chief Learning Officer can point you to those or maybe help you create new materials. I'd like to thank the TowerS team, particularly Kashad Bowman, Tristan Clintworth, the Office of the Chief Learning Officer, the GOES-R and the JPSS program, our facilitator, presenter, and all of you for being with us today. Without further ado, Justin is a meteorologist at the Forecast Office in Duluth, where he has been for nearly 5.5 years. Before coming to Duluth, he was a Met intern in Milwaukee. In total, he has nearly 8 years of operational weather service forecasting experience. He started his professional career as a research associate at the University of Oklahoma Cooperative Institute for Mesoscale Meteorological Studies, now renamed, at the Weather Service Training Center in Kansas City, Missouri. While there, he developed distance learning modules on forecast tools, including EWIPS 2 programs such as GFE, BOIVerify, and CHPS. Justin holds a bachelor's degree and master's degree in meteorology from Iowa State University. Justin, thanks for being with us today.
Let's see. Thank you so much, Jordan, and thank you to you and the other TowerS folks for inviting me for this presentation. So earlier this month, I had given this presentation for the Great Lakes Operational Meteorology Workshop, and it's kind of the culmination of research that I did along with my SUE and my WCM in my office on the meteorological factors that lead to lakeshore flooding. This research, I'll preface this before getting into the slides, but this research was done back in the summer and autumn of 2020. By then, we were just getting out of a very active period of lakeshore flooding, very impactful flood events that led to millions of dollars in damage across Western Lake Superior. Let's see if I can advance the slides. There we go. So why do we have such a really active pattern of lakeshore flooding across our region? So the first place that I started was looking at precipitation. So these maps are from NCEI's Climate at a Glance, looking at the statewide precipitation ranking. This first map is the 12-month period from September 2019 to August 2020. So right off the bat, you can see across, if we focus on like the Lake Superior Basin, you can see that of the 125 years of record, the state of Michigan seen its wettest 12-month period, as well as Wisconsin and Minnesota being up into the top 5 wettest 12-month on record. If we expand that out even further to 36-month periods, so looking at September 2017 to August 2020, things become even more stark. Now we're seeing both Michigan and Minnesota 123rd out of 123 years. So we're talking about really anomalously wet period that we're going through. And the state of Wisconsin is second wettest. If we go even further and expand that out to 60 months, then now you're starting to see not just the Lake Superior area, but also pretty much across the Great Lakes Basin. You're seeing multiple states 121st out of 121 years, wettest periods on record for Minnesota, Wisconsin, Michigan, Ohio, Pennsylvania. So it's no wonder that we're seeing the frequency of lakeshore flooding events really increased over the last 5 to 10 years or so. In fact, back in October of 2019, Lake Superior missed its all-time highest water level record by just 1.1 inches. So a near all-time record water level broken for Lake Superior, and I believe for some of the other Great Lakes, not only did they actually broke their record. So you can see that that little snippet from the Duluth News Tribune, and you can see here the water level trace off the NOAA's NOS co-ops gauge there. So you can see that really intense, quick uptick in the water level right as things really start to ramp up and lead to really impactful lakeshore flooding. So let's put this into an even starker terms. And actually, let's look at the water level comparisons over the last 2 decades for Lake Superior, comparing the lowest level to the highest level. And before going into the numbers, credit to Brandon Crumweedy, who is the Great Lakes Regional Geospatial Coordinator of NOAA's Office for Coastal Management. He did a presentation that showed these very numbers, and I thought that this was just mind-blowing what it revealed. So if we look at again that high mark back in October of 2019, the monthly average water level was 183.88 meters. Okay, but if we go back to the low mark, which was March of 2007, the monthly average water level then was 182.79 meters. So this is a change in water level of 1.09 meters in 13 years. If we take that number and convert it to kilometers and then multiply that by the area of Lake Superior, which you can see there, about 82,100 square kilometers, you have a change in water volume of 155.99 cubic kilometers. So exactly how much water is that? That is roughly equivalent to 41.2 trillion gallons of water that is just being put into Lake Superior. That's enough water to fill approximately 62,400,000 Olympic-sized swimming pools. So we are just talking about an incredible, astonishing amount of water that we are just putting into Lake Superior. This is just Lake Superior. This is not even talking about the other Great Lakes. So we're talking about just a staggering amount of water that's being put into Lake Superior. So no wonder that we've had a higher frequency of lakeshore flooding events, not just for Lake Superior, but across the Great Lakes Basin. So moving on to the water level traces off the GLERL's Great Lakes dashboard here. So how to interpret this is the red line, the solid red line that you see is the Lake Superior long-term average water level. So that's this water level goes back several decades into the 1900s. Each solid blue line that you see, that's the average, the annual average water level, and then each blue dot shows the monthly average water level. So you can see in the red box here is when we started going from, right up, below average to that long-term average, and then basically staying above that red line, staying above that long-term average water level. So the period that we will focus on is really 2007 to 2019, or I'm sorry, 2017 to 2019. Is really when this research really looked at a lot of these lakeshore flooding events and tried to determine the meteorological factors that led to this lakeshore flooding. So one important factor is orography. And you might be thinking, well, what exactly does terrain have to do with lakeshore flooding? Well, in this situation, it has quite a bit to do with it. And the reason being is for those that haven't been to Duluth or haven't gone up the north shore of Lake Superior, hopefully you can see my mouse cursor here. So, but I'm highlighting the north shore, the gradient in terrain, very sharp terrain change. So, in many places along the north shore, you're seeing an elevation change of like 800 to even 1,000 feet. So in the events that you have an approaching, area of low pressure, mid-latitude cyclone, and you have winds that are more from like the east or northeast, you get this blocked flow. It's what we call blocked flow. So very strong mass convergence along the north shore as it kind of rams up against the higher terrain, and that wind will then be funneled down the southwestern arm of Lake Superior towards Duluth and Superior, Wisconsin, which we call the Twin Ports. So it's very common to have recorded wind speeds or observed wind speeds in the Twin Ports like 5, 6, 7 knots or more, greater than what a lot of the forecast models show. So they struggle a bit with this blocked flow. So you have these stronger winds that are funneling right towards the Twin Ports, ultimately leading to building waves, and there you are. You have a recipe for lakeshore flooding, especially when you have these near record water levels. So another way to depict this elevation change is from this image on Google Earth, showing the elevation change from downtown Duluth to what we call on top of the hill. The crest of the terrain there, 800 to 1,000 feet. So now let's talk about the cases that we examined. These particular cases, these 5 here, represent probably the cases that we really ramped up our messaging. Our IDSS, our decision support services, the messaging was really heightened for these lakeshore flooding events. In total, these events accounted for approximately $28 million in total damage. And to kind of help keep the dates straight, the very first one, the eye-opening case was late October of 2017. Before then, you'd have to go back nearly 15 years before you had the next, the most recent lakeshore flooding event in Duluth, Minnesota. And then from that late October 2017, basically alternating from April to October to April to October, all the way through to 21st of October 2019. So for the analysis that we looked at a few different things. So the meteorological factors we looked at was, number one, the residence time of the wind flow. Was there a certain duration of the winds across western Lake Superior that led to building of waves and increasing water level? Number two, the strength of the wind. Was there a certain magnitude, a certain threshold that needed to be met where lakeshore flooding became more probable? And I also looked at, given this magnitude, how does that relate to what kind of headlines we had out? So things like small craft advisory, gale warning, or storm warning criteria. Which, by the way, small craft advisory, that starts at 22 knots, goes to 33 knots, and then gale warning is 34 to or yeah, 34 to 47 knots. And then storm warning is basically anything 48 knots and greater. Next, we looked at the wave heights. So is there a particular wave height threshold that must be met or exceeded to support lakeshore flooding? And we looked at this more, in a forecast perspective. So we looked at the Wave Watch 3 wave heights to kind of base this on. And then finally, the water level. Was there a particular water level threshold that needed to exist for when lakeshore flooding becomes more common? So all this analysis, we focused on one particular site. There is a airport, the Sky Harbor Airport, which is an ASOS. The 3-letter identifier for Sky Harbor is DYT, and it's located here along this thin strip of land that protrudes from downtown Duluth. So this strip of land is known as Park Point. There's a little kind of a description of the area and kind of some of the neighborhoods that I'll be talking about. So Park Point, there's a lot of residences. There's a lot, of beaches there that basically face Lake Superior. So we did see a lot of beach erosion from these particular events. If you follow Park Point to the northwest and where it joins basically downtown Duluth, that area is called the Canal Park area. So there's a lot of businesses, restaurants. That area in particular took a real pounding from these waves. And then further to the North Shore, there are a number of other beaches that saw a lot of sediment transport and a lot of other beach erosion. So this is the area that we will primarily be focusing on for the impacts for these events. So now that we've got that out of the way, let's look at the data. First, let's look at the wind direction. So looking at the Sky Harbor windrows plots generated from the Iowa Environmental Mesonet, you can see that largely the flow direction, the wind direction, is primarily from the north and northeast, which kind of, going back to the terrain slide, that makes a lot of sense. You get that, the east and northeast flow, and then you have that blocked flow along the higher terrain, and it funnels down towards Duluth. So this was not a very surprising find. You'll notice for the upper right particular case, this was the 10th and 11th of October 2018. The Sky Harbor Airport was actually down at that time, so we found a nearby substitute basically to generate the windrows plot there. Next, we looked at the mid-latitude cyclone tracks. There's not a whole lot of peer review journals on lakeshore flooding, but there was one that I came across, Melby et al. 2012, and they had concluded that most of the non-convective extratropical cyclones that led to lakeshore flooding across Lake Michigan, not Lake Superior, but Lake Michigan, took a southwest and northeasterly track. So that seems reasonable for our purposes in Lake Superior, given the influence on the flow regime. So for these 5 events, is that what we saw? Well, let's take a look. So I used the ensemble situational awareness table to plot the mean sea level pressure. So I know that there's like the climatological percentiles and standardized anomaly shading here for these, but just ignore the shading. And I just want you to focus on the track of the surface lows. And to help with our analysis, I went ahead and drew in the approximate track. So there's a couple of things that stick out to me here. The first, going back to Melby et al. 2012's paper, is they were mentioning the southwest and northeast track in the surface low, and for a couple of our cases we saw something similar, but that's not always the case. As you can see in the top center, that was the mid-April 2018 lakeshore flooding event, where the surface low basically stayed to the south of our region the whole time. So I think the key takeaway for this is, again, the the proximity of the low track to Lake Superior. Basically, where is it located relative to Lake Superior? And largely, the tracks have stayed to the south, where it makes a lot of sense. You have the cyclonic circulations around the surface low, more of that east, maybe perhaps some northeasterly flow regime over Lake Superior, and then all that wind funneling down towards the Twin Ports. So summarizing the rest of the data, looking at the second column here, the duration of the wind. And this is, some of this analysis was actually pretty easy. You can tell when the influence of the surface low is really felt, when the winds really start to ramp up, and then when they start to kind of taper off at the end of the event. So for each of these events, we had a flow duration at least 24 hours for 4 of the 5 cases. The only exception was the last one, the most recent one, the 21st of October 2019, where the duration of the flow was about 16 hours. That middle column, the strength of the wind, there's some variability here, but the strength of the wind was more like generally around 25 to 35 miles an hour sustained, and then gusts about 35 to 45 miles an hour. With the gusts in that range, that puts us in the gale warning criteria. And in fact, for all 5 of these events, we had gale warnings in effect. Now, some of them we did have to upgrade to storm warnings. So we can kind of think from a forecast perspective that, okay, if we have like the duration of the flow of 24 hours that are gale warning strength, then, and if we have, the appropriate, I guess, if you will, water level, then that should be enough to support lakeshore flooding. The last thing that we looked at was the forecast wave heights off the Wave Watch 3 guidance. So on the low end, about 12 to 16 feet, but there were some events where we had 15 plus. So we can, kind of think of 12 to 16 as kind of our lower end, and 15 or more feet for wave heights. That is when, the threat for lakeshore flooding starts to ramp up. So again, we also looked at the water levels in Duluth. So this data was provided from NOAA's Tides and Currents page. So I was able to download the data and plug it into Microsoft Excel to generate this plot. So right off the bat, we can see that all 5 of these events had a water level of 603 feet at least. And 3 of the events we had exceed 604 feet. In fact, the orange line here, which I'm trying to highlight there on like under the day 5 area, so that basically is when we almost hit our record water level for Lake Superior. So let's shift gears and go from the forecast side of things to the impacts. What exactly did we see with these events? The list to the left is kind of a comprehensive list of some of the impacts that you could see with lakeshore flooding. Now, we didn't see all of these, but we did see quite a number. So we had some shoreline erosion, increased sediment transport, damage to coastal infrastructure, which I'll show here in the next slide. Things like shrinking beaches. There was a lot of beach erosion, especially along the Park Point area, and damage and loss to property. So we saw a number of these impacts across the region. So I want to show some of the pictures in the video that we took from these events. Starting with the very first one, that 27th of October 2017 impact. So you can see a lot of the shoreline erosion there, leading to this tree toppling over, and the very popular tourist area, the Duluth Lake Walk, was completely battered. You can see the boardwalk there left in pieces. So the Lake Walk area, I mean, that attracts millions of visitors every year. So to see this was really quite something, very eye-opening. If we go from the Twin Ports and look to the east, closer to Ashland, Wisconsin, you can see a lot of the like the erosion that led to buckling of this parking lot here, and even some water pushed over Highway 2, which is a very heavily traveled road over Ashland, Wisconsin, inundated with the waters of Lake Superior there. The other, some of the other impacts that we saw, this is the second case. So you can see, really large waves building, and especially if you look at the video, this one particular wave hits the bottom of the Duluth aerial lift bridge. So if that's a really large wave. If you take the water level when it's more quiescent and go to the bottom of the aerial lift bridge, that's about 15 feet. So we're basically looking at one 15-foot wave here that's hitting the very bottom of the lift bridge. The middle case, this 10th, 11th October 2018 impact, you can see basically getting away from the canal there and looking at some of the parking lots nearby. You can see all these vehicles being inundated by the floodwaters, impacting some of the nearby businesses. This red building to the left, this is the Grandma's Restaurant, very, very popular restaurant there in the Canal Park area. As well as this video here that shows the waves really, pounding that Canal Park and that area where the Park Point and downtown Duluth meet. Now, on to this particular case, which I consider a null case for these 5 cases, because there actually was very little impact from this. And you can see why, is because we had a very strong push of lake ice into the region, which actually helped to dampen the waves. If you look at the video to the right, you can see some of these waves, earlier they were really, really large, but now they've pretty much dampened out. So that's one challenge that we forecasters have, is trying to anticipate the push of the ice, because we had lakeshore flood warnings out for this particular event, but the impacts were little, if any. That was because of that lake ice being pushed in. So it's one challenge that we have as forecasters is anticipating the ice. And really, when we do our wave height forecast, we do ingest an ice mask into GFE, into our forecast system, but it's static for the entire 7-8 days. It's not a dynamic ice mask. So that's one challenge I know is being looked at by the folks behind WaveWatch 3 and at GLERL. So really looking forward to kind of being able to better tap into a dynamic ice mask there. The final event, the 21st of October 2019 impacts, you can see here lots of debris and sediment transport. The top 2 images show a before and after at Brighton Beach, which is further up the North Shore from Duluth. Lots of additional erosion along the Duluth Lake Walk there. And this particular event was unique in the sense that there actually was a wireless emergency alert that was sent out, a WIA alert for the people on Park Point. You can see there, people on Park Point shelter in place due to flooding. And I will never forget, I was working the day shift on this particular event, and I was at home watching the news, and live on TV, everybody's smartphones were going off with the WIA alerts, so including my own. So that was really quite something to see. And you can see some of the officials of the city of Duluth putting up barricades to ensure that people don't drive into the floodwaters there. So you'll probably notice by now that a lot of the impacts that we saw were Duluth centric. That's really easy for us to know the impacts in Duluth, given the extensive webcam network in place, and along with being, the largest population center of our CWA. But what about the rest of Western Lake Superior? How can we know the impacts across the rest of the region? Some cases it can be really difficult since a lot of the shorelines are more rural. So during the process of this research, myself and my WCM and Sue, we joined a community of practice known as CHAOS, or the Coastal Hazards of Superior, which is comprised of these particular entities like NOAA Sea Grant, Minnesota Department of Natural Resources, National Estuarine Research Reserve, and Wisconsin Coastal Management Program. So through this research and through our collaboration, a website was made known as the Lake Superior High Water Spotter. So what this will do, and if you're curious, you can find, you can go to the URL at the bottom of the slide and take a look yourself. But what this page will do is it allows people to take a picture with their smartphone and upload it with their location and date and time that they snapped the photo, and then upload that photo and that information. That way we can create kind of an online timeline of the impacts that we're seeing across Lake Superior and how the shoreline evolves with time. You can see one picture here along the north shore of this down tree here, and you can see like the photo date and time, June 2nd, 2020 at 12:15 p.m. So we can see how things change with time. So you're probably thinking, well, up to this point, I haven't said anything about satellite. You know, this is the Satellite Book Club after all. Well, I think one challenge that we also see is maybe perhaps there is an application here for satellite, an unmet need, that using satellite we can observe lakeshore flooding in real time, and not just for the Duluth area, the Twin Ports area, but elsewhere across Western Lake Superior and really elsewhere across the Great Lakes, because lakeshore flooding is not just a problem that we're having in Western Lake Superior, but they're having elsewhere in certain spots across the Great Lakes. So maybe perhaps this can spark some discussion and some thoughts of that. Maybe perhaps there's an unmet need here for lakeshore flooding. So wrapping up my presentation, here's the reference to the Melby et al. 2012 paper. I'd like to give special thank you to my Science and Operations Officer, Patrick Ide, and my Warning Coordination Meteorologist, Joe Moore, for their guidance throughout this research. And with that, I'll wrap up here and I'll take any questions.
Thank you, Justin, for that really great presentation. I'd like to first encourage all the attendees here to stay on for the discussion point, and please, it would be really appreciated for those that are in other field offices and the regional headquarters that, as Justin was saying, maybe there's some unmet need for satellite applications. So maybe there's some ideas that are out there. So please put your full name in the chat when asking the question. Also in the chat, there is a link to the feedback survey. Please fill that out. It's important to hear the feedback on the about these satellite book clubs. As Jordan mentioned, a week from today, on Thursday, June 2nd, at 11 a.m. Eastern, Brian Kern and Devin Chihak from the WFO in Midland, Texas, will discuss the May 18th, 2021 long track tornado. This is, as Jordan mentioned, the 100th session, so there will be special guests, hopefully. And as always, if there are any questions on how to about the Satellite Book Club itself or configuration of satellite products, please contact the Tower S team, Lee Byerly and Kajan Bowman, for any questions on these. And of course, John Emmons, I should mention as well. He's done a really great job. So with that, I think we'll start with some of the questions that are in the chat. I will pick up Mark DeMaria is asked the question of, is all the flooding due to wave action, or is there some component to storm surge that's possible cause for the flooding?
Yeah, so it's largely due to the wave action. One thing that's interesting, if you look back at or if you think back to like the Google map that I showed, if you have, all this northeast flow and you have all these building waves, that just kind of gain momentum with time, there's really nothing slowing it down. Once it gets to like the Park Point Beach area, and the Canal Park area, the Duluth aerial lift bridge area, there's really nothing to slow it down. It's just, these waves just build, and that's kind of why you saw that really large 15-foot wave hit the bottom of the lift bridge. It's because between that point and further upstream where all these waves build, it's just a constant building of the water and the waves all the way there. So there's nothing really to mitigate the wave action.
Yeah, actually, I was going to follow up with the question of if there had been any mitigation strategies in the Duluth area to sort of address some of those infrastructure, there's a lot of damage there and soil erosion.
Mm-hmm. Yeah, so that's a good question. And I did tack on, let me see if I can advance the slide. Here we are. So I did tack on this image. This is from the Minneapolis Star Tribune newspaper from last June when the Lake Walk reopened. So before the Lake Walk was battered by all these, I mean, you had like the boardwalk here, which you can see these two people walking on, and you had some boulders here, but it was not very many. So basically what they did after the damage was done is they rebuilt this stone boulder wall, if you will, right here. And what you're looking at here is altogether, I think it's like 100,000 tons of stone boulders here to help break up the waves. So that's basically the first line of defense against lakeshore flooding. And the second one you'll see right here is this concrete barrier on the outside of all these boulders. This concrete barrier is 18 inches wide and 10 feet deep, goes 10 feet into the ground. So that's the second mitigations, kind of the barrier of mitigating all this damage. And then if any waves were able to get towards like the boardwalk and beyond that, you can see there's a lot of trees, or I shouldn't say trees, but shrubbery and mulch here, a lot of landscaping. Underneath all of that is actually a like a storm water system that basically will take the water and pump it back towards Lake Superior. That way it doesn't impact some of the buildings and structures and businesses on the other side there. So that's a big part of the mitigation strategy for mitigating lakeshore flooding. The other thing that they did too is because there was a lot of beach erosion on the Park Point beaches, they did a lot of movement. It was really neat to see a few years ago, there was a Park Point webcam that actually showed a lot of the movement of the sand and sediment to basically try to reestablish the beaches there. And I don't think that there's been anything like this along Park Point, but they did put in a lot of time to rebuild those beaches along Park Point.
Yeah, getting to the usage of satellite data, Scott actually brought up. I think there was a satellite. I'm pretty sure there was a satellite book club on this about the usage of synthetic aperture radar winds. Really high resolution winds, and he said it seems like those sorts of observations might be used a little bit more, because it can show, like, for example, I guess from yesterday's imagery, there was a distribution of, northwest winds over all of Lake Superior that would funnel down into the Duluth region. Has there been some thought to try to bring in, obviously there is Sentinel data, but, is bringing in the RCM data, which provides it's a higher temporal cadence than, the Sentinel SAR data sets.
Mhm. Yeah, there's a couple of different tricky things about like the satellite, and I've had some discussions with my Sue Patrick about this very thing. Is that there's a couple of different challenges with that. Is one, you need a high enough temporal and spatial resolution to capture the lakeshore flooding, because I mean it really is a small phenomenon in the grand scheme of things, compared to these large mid-latitude cyclones. So you really need that high temporal resolution and high spatial resolution as well. The other tricky thing is that each of these events happen with, like I said before, it's just these really large, strong, anomalously strong mid-latitude cyclones that form and generate this really large cloud shield. Makes it really hard for certain satellites to kind of pierce through the clouds. So that's the other thing that needs to be done, is be able to see through the clouds and be able to see it, it almost in real time, and have the high enough spatial resolution. So it's quite tricky to find kind of something that's suitable for this need. But that's kind of why I brought it up, is that maybe it's something that we're not thinking of, or maybe perhaps this is something that can be built on, in the future.
So Jordan, make that as a note, as the wish list is a geostationary SAR instrument for the next generation of geostationary satellites. Because SAR is, of course, having my background of flooding, that's the king when you don't have when you have cloud cover during these flood events. You need SAR to complement the optical imagery. I guess we don't have time for the last question. So I'm going to pass it back to Jordan for final closing remarks.
Okay, thanks. I don't know, Justin, if you wanted to just address that last question very quickly.
Yeah, I can stick around.
Okay, let me wrap up here, and then if people want to hear the answer to the last question, they can. So once again, please join us for the 100 Satellite Book Club next week, Thursday, June 2nd at 11 a.m. Brian Curran, Devin Chihak from the Weather Service Forecast Office in Midland, Texas, are going to discuss a long track tornadic Permian Basin supercell. I hope you will be able to join us. In the meantime, if you need any assistance with satellite data for your forecast office, please get in touch with our TowerS team. Their email addresses are there on the screen, or you can reach them via the NWS chat. With that, I really appreciate everybody attending today, and I specifically would like to thank Justin for that engaging presentation, and to William for moderating and facilitating the subsequent discussion. With that, that's a wrap on the 99th session of the Satellite Book Club. We will see you next week. Take care, everybody. Stay well.